Okay, in 2.3a we are looking at product rule and trig derivatives. And so first up we have those trig derivatives. There are 6 of them that we are looking at in this lesson. There are a few more that you'll actually learn next semester, which will round off our trig derivatives. But for this semester, these are the 6 trig derivatives that you will be responsible for. You have your derivative of sine, which is cosine, derivative of cosine, which is negative sine. We learned these in the last lesson. They are our basic trig derivatives. And there are 4 others that are born in some way, shape, or form from these 2 base derivatives. And again, they're formed in different ways. And as I said with sine and cosine, if you are ever wanting to see why the derivatives are what they are, I am more than happy to show that to you. So you could ask that in class. You could email me and ask for a video, whatever you would prefer. But again, as I said when we walked through sine and cosine together in class, we want to make sure that we have these memorized. When you think about the AP test being a timed test, any place where you can save a little bit of time is going to be advisable. And so you're going to want to have these 6 trig derivatives memorized. Okay? But then there are ways to help you with that memorization. So besides our 2 basic ones, you'll notice that the derivatives of tangent and cotangent are very similar. Tangent is secant squared, cotangent is cosecant squared. Right? Secant and tangent are very similar. Secant is secant tangent, derivative cosecant is negative cosecant cotangent. Right? So you'll see some similarities there. Notice that all your co-functions, when we take their derivatives, all of their answers are negative. Right? And for many of our cos, not all of them obviously, but for many of them, cos stick with cos, right? So cotangent is cosecant squared, cosecant is cosecant, cotangent, cos stick with cos to a large extent, versus like tangent, which is secant squared, secant is secant tangent, no cos over here. The obvious exception being our 2 base ones. Okay? And so there are kind of memorization tools that you can use to help you get these 6 down. But once you have them, it really then becomes plugging them into their appropriate spot, right? And so maybe you want to do flashcards or something like that, but you'll be plugging them in as you take the derivative of particular trig functions, right? So as you take the derivative of secant, you're going to do secant tangent. Right? Okay. The other rule then that we are looking at today is product rule. So product rule answers the question, how do I take the derivative of 2 functions that are multiplied together? So unlike the base derivative rules that we looked at in our prior lesson, product rule, quotient rule, which you'll learn next week, and chain rule, which will also be next week, all 3 of those have special rules that you have to use. And again, the reason why comes out of that definition of derivative. Again, I'm always happy to show you why if you would prefer. But again, at some point it becomes a memorization thing, which is that if you see 2 functions being multiplied together, we're going to call them 1 and 2. So one function being multiplied to a second. Okay, then you would leave the first function alone. So f of x stays f of x. You'd take the derivative of the second function. So g of x, its derivative would be g prime. Plus the second function, you would leave it alone. And then the derivative of the first. And so my saying, quote unquote, for product rule is 1d2 plus 2d1, what we wrote up above here. Which again is just our way of kind of mentally walking through that rule and reminding ourselves of what we have to do. Okay? And again, you have to use product rule anytime you see 2 functions multiplied together. And we're talking functions, not a coefficient, like a 5. If I see a 5 out front, I have no issue with the 5. If I see a 5x squared out front being multiplied to another function, that's then when I have to use product rule. 2 functions multiplied together, 2 x components being multiplied together. Okay? And so we have 6 of these just to walk through them, give us a chance to look at product rule, and then we'll practice some more in class on Thursday and Friday. And so example 1, let's walk through this one together just so you can see what it looks like. So Find the derivative y equals x squared times sine x minus 5x cubed. Right here, where you see two functions being multiplied together, two x components being multiplied together, that's where you're going to do your 1 and 2. This is going to be the product rule element here, right? Because I have multiplication, I have a product in here. 5x cubed is just its own thing, so I'm going to treat it by itself. Okay? So we have y, so we're going to do dy dx equals, and then taking the derivative, product rule is 1d2 plus 2d1, right? So at 1, I'm going to leave my function alone, right? That first function is going to stay exactly the way it is. So it's going to stay x squared. d2, I'm going to take the derivative of that second function, right? So derivative of sine x is cosine x. Plus, and then 2, my second function left alone, so my sine x left alone. d1, the derivative of the first function. Derivative of x squared, that's power rule. So I'm going to bring the 2 down in front, leave the base alone, subtract 1 from the exponent. Okay? And then back here we have our 5x cubed, which is power rule. So 5 is just a coefficient. I'm going to let it hang out. Bring down the 3. 5 times 3 is 15. Leave the base alone. Subtract 1 from the exponent. Okay? And we have our answer. We have x squared cosine x plus 2x sine x minus 15x squared. Okay, and so all the rest are just going to be chances for us to practice our derivative rule here, learning to identify when product rule is at play and then using product rule on that spot. And so if you want to pause the video at some point, and actually not even if you want to, I would encourage you to at some point pause the video and try some of these on your own. Don't wait for the end. Do it sooner rather than later, right? Even if you get stuck, okay, you get stuck. You restart the video, you hear the explanation, right? But you need to be practicing these on your own. That way you're figuring out, where are my questions, right? Where am I getting stuck? And write them off to the side. Highlight that spot. You have this whole space over here that you can put questions on if you would like. On example 2, why fill in the blank, right? But come into class ready to ask. Okay? So here we go. Derivative of f is f prime. Okay, this one's just power rule, so I'm just going to do power rule on it. Bring down the exponent, leave the base alone, subtract 1 from the exponent. Okay, back here we have two things being multiplied together. So I have a positive x squared, that's going to be my 1, and I have a cosine x, which is going to be my 2 for product rule. Two things being multiplied together. Okay, and so 1, which is the first part of my product rule here, right? Leave the f of x alone. It's going to be my positive x cubed. d2, derivative of the second derivative of cosine, is negative sine. Okay. Plus 2, my cosine x, g of x left alone. d1, bring down the 3, so we have positive 3, leave the base alone, subtract 1 from the exponent. Okay, and that's your derivative. Okay, example 3. Again, pause the video, try some of these on your own. Derivative of y is dy dx. Okay. 4x squared, that's just power rule. 4 is a coefficient, so I'm going to let it hang out. Bring down that 2. 2 times 4 is 8. Leave the base alone. Subtract 1 from the exponent. And then we have two functions being multiplied together. We have a negative 3x squared and a secant x. Okay, so product rule. 1, negative 3x squared. D2, derivative of secant is secant tangent. Okay, plus 2, my secant x left alone. D1, so negative 3 is a coefficient. I'm going to let it hang out, bringing down that exponent. You have negative 3 times 2, which is negative 6. Leave the base alone, subtract 1 from the exponent. Okay, and then that's your derivative. Okay, example 4. Take a look at example 4. Pause the video if you're going to. Derivative of y is dy dx. Okay. And then two functions being multiplied together, so we're going to do product rule on them. This is my first and my second. Okay. So product rule. 1, my 8x to the 5th. D2, the derivative of cotangent, is negative cosecant squared. Okay. Plus 2, my cotangent x. D1, the 8 is a coefficient. I'm going to let it hang out, bringing down that 5. We'd have 40, leave the base alone, subtract 1 from the exponent. And that's your derivative. Okay. Example 5. Again, pause the video if you're going to. Okay, derivative of y is dy dx. Two functions being multiplied together, so there's my 1 and my 2. Okay. So product rule. 1, 3x minus 5. D2, okay, derivative of x, right, this is x to the 1, for example, right, bringing down that 1, leave the base alone, subtract 1 from the exponent. 4 is a constant. What's the derivative of your constant? That would be 0. Okay, so that's my 1d2 plus 2, x plus 4. D1, okay, 3x, exponent of 1. 3 is a coefficient, so I'm going to let it hang out. Multiplying that 1 to it, we have 3, leave the base alone, subtract 1 from the exponent. 5 is a constant, so what's the derivative of 5? And that would be 0. And cleaning this up, we have our 3x minus 5. This is times x to the 0 is 1, right? Plus 0 is 1. And our x plus 4 times x to the 0 is 1 times 3 is 3 minus 0 is 3. So you actually could simplify this pretty far. Distributing that 1 would be 3x minus 5. Distributing the 3 would be 3x plus 12, which is 6x plus 7. If you wanted to go all the way combining like terms. Okay, and then one more just to remind ourselves that we can plug in points, right? Remember, that is what a derivative is doing. It's finding the slope at all the points along a function. Okay? And so here, find the slope of the line tangent to. So we have our, let's go ahead and take our derivative first, dy dx. Pause the video if you're going to. Take the derivative of that function. Okay, we have two functions being multiplied together, so that's product rule. Okay, so 1 is x, d2, derivative of secant, is secant x tangent x, plus 2, which is my secant x, d1, and so this has an exponent of 1, so it's power rule, bring down that exponent, leave the base alone, subtract 1 from the exponent. Okay, and so my derivative is x secant x tangent x plus x to the 0 is 1 times 1 plus secant x is secant x. And so my slope, since x is pi here, would be pi times secant pi tangent pi plus secant pi. Okay, pi is this angle here at -1, 0, so cosine is -1, sine is 0. So secant of pi would be 1 over my cosine, or 1 over -1, which is -1. Tangent of pi is sine divided by cosine, 0 divided by -1 is 0. And secant of pi, again, is 1 divided by cosine, 1 divided by -1 is -1. And so this is 0 plus -1, which is -1. Okay? That's product rule.